So here there's going to be a bunch of little mini videos. In this video I'm only going to cover problems 1 through 4. I'll have these labeled nicely in Edpuzzle so you can see, like, if you're stuck on number 3, obviously click on the video that says questions 1 through 4. Alright, so we'll start number 1. So number 1 is asking me to divide rationals, or to divide a fraction by a fraction. So there's a couple different ways that we can do this. We can flip the second fraction first, because when we're dividing fractions, we need to flip the second fraction, and then our division sign turns into multiplication. So you can flip it first, or we can factor everything first. I don't really care which one you do. Both roads lead to the same destination. So I'm going to go ahead and factor everything and flip it all in one step. So hopefully you're listening to the audio, or this may seem like a magic trick. But I'm going to factor everything. I'm going to write everything in factored form, and I'm going to flip the second fraction, just for space purposes. But we're pre-AP, we can handle it. So the top left, 2x squared minus 18, I'll talk about for a brief second, but 2x squared minus 18, we need to factor a 2 out first. Because after we factor out a 2 from 2x squared minus 18, we're going to have 2 times x squared minus 9. I don't know how to factor 2x squared minus 18. I do know how to factor, theoretically, x squared minus 9. If you don't remember difference of squares, just multiply a times c. They have a b of 0, and a times c needs to add to the 0b value. So if you don't have to memorize difference of squares. If you've forgotten that, we can factor the long way if you need to. So 2x squared minus 18 turns into 2 times x squared minus 9. X squared minus 9 turns into x plus 3. X minus 3. The bottom part, x squared minus 6x plus 9. I need two numbers that add to positive 9. Sorry, I lied. I need two numbers that multiply to positive 9 and add to negative 6. So these two numbers that I choose have to multiply to 9 and add to negative 6. Well, my factors of 9 are 1 and 9 and 3 and 3. So obviously we're going to pick 3 and 3. And if I want negative 6, then both of my 3's need to be negative. So it's just going to be x minus 3, x minus 3. All right. Again, if you flip the second fraction, our sign turns to multiplication. So that's not division anymore, it's multiplication, because I'm about to flip it. So x minus 3 was on bottom. Now it's on top. Again, I didn't factor the top, I flipped the fraction. So now we have to factor x squared plus 6x plus 9. And I know this problem is worst case scenario where you have to factor 30 things in one problem. But we'll set you up with the worst case on the review, so hopefully the test seems easier. So x squared plus 6x plus 9. Again, I need two numbers that multiply to 9, but this time they need to add to positive 6. So we're going to do 3 plus 3. So it'll be x plus 3, x plus 3. Now, when you're multiplying, I know everybody teaches this and does this a little different, but when you multiply, I would just make one giant mega fraction, because when you're multiplying rationals, everything that's on top of both individual fractions will go on top of a big fraction. Everything that's on bottom of the individual fractions will go on bottom of a big fraction. So just to save time and not write the same thing again, we'll just make one big fraction line. And all of that's on the numerator, and all of that's on the denominator. And now to finish simplifying this, anything that you see on top and bottom gets wiped out. It cancels out. So I have a 2 on top. I don't have a 2 on bottom, so that's not going anywhere. I have an x plus 3 on top and an x plus 3 on bottom. I have an x minus 3 on bottom and an x minus 3. I have an x minus 3 in the numerator and an x minus 3 in the denominator. So when we simplify this, everything canceled except my 2 didn't go anywhere and one of my x plus 3's didn't go anywhere. And when we're multiplying or dividing rationals, whatever does not cancel out, whatever we are not able to simplify, that's our final answer. So you cancel everything you can, and whatever's left over is your answer. Sometimes it'll be 10 things, sometimes it'll be something simple like 2 over x plus 3. All right. Number 2. Number 2 asks us to solve for x, and it's a square root. So if we have a square root or a cube root or a log or basically any type of solving, the complicated looking part needs to be by itself. So here the square root of x minus 3 needs to be the only thing on the left side of my equation. That's it, just x minus 3. So if I'm trying to isolate my square root of x minus 3, the first thing we need to do is minus 3 from both sides, which leaves me with 5 times the square root of x minus 3 equals 20. And if I'm trying to get the square root by itself, I need to get a new pen out. This one's not working. If I'm still trying to get the square root by itself, we're going to cancel out our 5. So we need to divide both sides by 5, which leaves me with the square root of x minus 3 equals 4. Now, if I need to cancel out or get rid of a square root sign, which is my goal here because I'm trying to get x equals when I'm solving. So if I need to cancel out the square root sign, I need to square both sides. If it was a cube root, I need to cube both sides. If it was the fourth root, I would need to raise both sides to an exponent of 4. So since this is a square root, I need to square both sides. Now be careful here. This is not x minus 3 squared. The square root of x minus 3 squared, when you square a square root, all you're doing is canceling out the radical. You're just canceling out the square root sign. So my left side is only going to be x minus 3 because the squared cancels out the radical. And then 4 squared, 16. And then to finish getting x by itself, no explanation needed there. You just add 3 to both sides. So here x equals 19. In this case, it doesn't matter. On your semester exam, I don't have every question memorized, so it may or may not matter. But be careful, we can't take the square root of a negative number. So if you plug in x equals 19 and got a negative under the square root, then it's extraneous. So if you see the word extraneous on the test, we can't take the square root of a negative number, and we cannot take the log of a negative number. Here's your little tangent for number 2. Number 3 says graph y equals x plus 2 over x plus 4. Now here graphing this is not graphing 2 lines. I don't want to see you graph x plus 2 and then graph x plus 4. With rationals, there are some different pieces to the puzzle here that we need to graph. Obviously, we can use y equals and graph this in our calculator and give a pretty good sense of what our graph looks like. So I'm not going to go crazy into how to find x and y intercepts and all that stuff because we can use our calculator. And if you don't know how to use your calculator, come talk to me and I will show you how to graph in your calculator. But that's doubtful. So in math, there's a few things we can't do. We can never divide by 0. Under no circumstance can we divide anything by 0. If you think logically about it, it makes no sense. So any x value that gives me 0 in the denominator or gives me a 0 on bottom is no good. We have to throw it away. So if you look at number 3, the denominator of my fraction is x plus 4. So if x was negative 4 plus 4 is 0. So if I had an x value of negative 4 on this graph, I would be dividing by 0, which we know is no good. So that means the x value of negative 4 will not exist on my graph, which, with rationals, those values that we're going to avoid are called asymptotes. And if we're avoiding an x value of negative 4, we need to have an asymptote or a dotted line at negative 4. So there's 2 kinds of asymptotes on rationals, if we remember. There's vertical asymptotes and horizontal asymptotes. Vertical is what we just did. It's any factor in the denominator that gives me an x 0 on bottom makes a vertical asymptote because we can't divide by 0. Horizontal asymptote is a little trickier. There's the rules we need to follow where we look at the degree of the numerator, the degree of the denominator. If they're the same, we divide the coefficients. If the degree of the numerator is greater than the denominator, so if the top degree is greater than bottom, we don't have an asymptote, and if the degree on bottom is bigger than the top, we have an asymptote at y equals 0. So here, the degree of the numerator is 1 because we just have an x. The degree on the bottom is 1 because we just have an x. So we have an x on top and bottom, which makes the degree equal, which means we divide the numbers in front of x, so it's 1x on top and 1x on bottom. So you're going to divide 1 by 1, which gives me 1, which means we have a horizontal asymptote at 1. So we have a vertical asymptote at -4 and a horizontal asymptote at 1. And then this is where we can solve for a whole bunch of different stuff. Or you can use your calculator and figure out where the graph goes, which is what I would suggest. With multiple choice, you really just need to know how to find your asymptote and then look at the calculator. But if you want to get technical, there's a point here and a point here. So our curve looks like this. And then we have a point here. Oh, it's not graphing. Point there, and what in the world? There. And our curve looks something to that effect. Again, you won't be producing your own graph, but you will need to identify correctly, which really the only way we're going to miss this is not putting our asymptotes in the correct spot. Number 4 is adding and subtracting rationals and solving rationals all tied into one question. So this would probably be the nightmare question on the whole review, which is good that we're getting it out of the way with number 4. But here, first we need to subtract our rationals, which there's actually 2 ways to solve this one. I'm going to do what I believe to be the more efficient way. If you want to go a different route, as long as you understand what you're doing, the alternate route is fine, and we are going to end up with the same answer. So if you don't like this way, then throw it in the trash and do it the other way. So I need to factor x squared minus 2x minus 15 first. That way I can know what my common denominator is. So we have x squared minus 33. And then if I factor the bottom, it's x minus 5, x plus 3. And if you need help factoring, I'm here every day before and after school. In prime time if we still had it, but okay. So now I've got it all factored, which luckily there was only one thing I could factor. So now the way I'm going to do this is I don't like playing with fractions. So if we multiply all 3 fractions by the common denominator, we're going to get rid of all our fractions and just be left with a normal quadratic equation that is theoretically easy for us to solve. So when we multiply by the common denominator, I'm going to rewrite it. And this is about to get ugly. I'm going to rewrite it, but on top, I'm going to add the common denominator. And I'm just doing it in a different color so you can see that I'm adding the red piece to my original equation. And algebraically, as long as we do the same thing to all 3 of these fractions, we can do whatever we want. All right. Okay, sorry, that took a while. That's a lot to write. Now, the reason we do this is now anything that's on top and bottom of a fraction we can get rid of. So in my first fraction, we have x minus 5, x minus 5, x plus 3, x plus 3. In my second fraction, we have x plus 3, x plus 3. And in this fraction over here, we have x minus 5, x minus 5. So that leaves me with x squared minus 33 minus 3x plus 15. So all I did there was distribute. And then equals x plus 3. So now all my fractions are gone. Now we are left with a quadratic equation, an x squared. Anytime you see an x squared, we need to get everything on one side of the equation. One side of my equation needs to be equal to 0. And we have two options. We can factor, which I believe is always the correct answer unless it's not factorable. Or you can use the quadratic formula. Quadratic formula will work whether the equation is factorable or not. So if you're looking to just use a quadratic formula on every quadratic and never worry about does it factor or not, quadratic formula is perfectly acceptable here. I will not be using it. So negative x minus 3. Oh wait, hold on. Let's clean up this left side first before I get carried away. So x squared minus 3x minus 18. Just combine like terms on the left side. And then negative x minus 3. Negative x minus 3. So that cancels and that cancels. So we're left with x squared minus 4x minus 21 equals 0. I'm going to move up here. I'm looking for two numbers that multiply to 21, negative 21, and add to 4. So I'm looking at 7 and 3, and if I need to combine 7 and 3 to get 4, it's going to be x plus 7, x minus 3. We set both of those equal to 0. So x plus 7 equals 0 means x equals negative 7. X minus 3 equals 0 means x equals 3. And as if this problem was not, just seeing if y'all are paying attention. I actually factored this wrong. Kind of. It's negative 4 in the middle. I thought that said positive 4. So if it's negative 4, then we need negative 7 and positive 3. So when we set these equal to 0, x equals 7 and negative 3. In math, we cannot divide by 0. So any x value that makes me divide by 0 is eliminated. So if you look at 7, if I plug in 7 to any of those three denominators in the original equation, I'm fine. I don't have a problem. If I plug in negative 3 to the first fraction or the second fraction, I get 0 in the denominator, which means negative 3 is no bueno. And that is what an extraneous solution is. So extraneous just means when we do the algebra, we find it to be an answer, but if we plug it in, it doesn't actually work. All right, so in number 4, multiply by your common denominator, factor at the end, but always check in rational equations, square root equations, and logarithmic equations, always check for extraneous solutions, especially if you get two answers. It's multiple choice, so 7 and negative 3 will be a guaranteed answer choice, but it's incorrect. You need to circle only x equals 7.